Dear friends, today we will find the refractive index of a glass slab and also the lateral shift. Here, for that we have a scale, we have glass slab, we have a protector, we have compass and some pins, right? First of all, let us put this glass slab here and let us draw the outline of this glass slab, right? Here we are trying to draw the outline of this glass slab. Here you see, we are trying to draw the glass slab in this way. It is square, that means order 90 degrees. Right, we have drawn the outline of this glass slab and putting the glass slab here, right? Let us put two pins at point. This point is A point, this point is B point. 2 points, one is green pin, another one is a red pin, right? We have put this pin and let us find the angle of incidence, right? For that, what if we do? I replace this slab and take out the pins, right? Here the pins is there. With the pins straight, make a straight line at this point Q. At point Q, first of all, at point Q, make a normal. You see, this is the normal. Normal is O1, N1. We made a normal here. Normal means 90 degree at the point Q. You see here. First of all, we make a normal or 90 degree. Let us take us the pin. Now, you see here. First of all, at point Q, we are making a normal. This is normal, means this is 90 degree to this surface, right? Now, we have taken two pins here at point A, green, and at point B, red, right? Now, with this line, make the incident ray. In this way, you have to take the straight line and removing the pins, red and green, make the incident ray. Here we made the incident ray. Now you can also measure the angle of incidence. If you measure the angle of incidence, you will find that the measure of angle of incidence is getting 30 degree. You see, this is 30 degree. That is angle I is 30 degree. Here you see that angle I, angle of incidence, angle I is 30 degree. That is, here I am writing here, angle I is equal to 30 degree. Angle I is equal to 30, angle of incidence is equal to 30 degree. After that, what will we do? Let us put the slab again. We got the incident ray, incident angle of incidence, and put the pins again. That is one at the point, previous point, green, and another one red pin, right? Now, what if we do? You have to look through this refracting surface, in such a way that if you put two pins here and all the four pins lie in a straight line, let us put two pins here, closing the eye and seeing that all the pins are in a straight line. Let us put first one green pin and another red pin. Another one is red pin. Let us put the red pin also. Right? We have to see with one eye closed whether they are in a straight line or not. Right? Now you see. Now I will show you that if you see through this refracting surface, let us see. Let us see through this refracting surface whether the four pins are in straight line or not. Let us see here. Let us see whether the four pins are straight line or not. If we see in this way, you can see through the reflecting surface that all the four pins are in straight line. Here you see, through the reflecting surface you can find that all the pins, that is green pin, red pin and the green pin and red pin, all are in straight line. With one eye closed, let us find whether all the pins are in straight line or not. Let us find. Here you see, with one eye closed, the pins red pin, green pin and again red pin are all in straight line. Right, you see here that all the pins are in straight line if you see through this glass slab. You see here? You see there are four pins, and if you tilt here all the lines we are getting green pin, red pin, and again the green pin and red pin are in straight line. Here see all the pins. Here there are four pins, you see 1, 2, 3 and 4. And if you shift this camera here, you will see all the four pins coincide with one another. Here see all the four pins coincide with one another. That means all the four pins, red pin, green pin, again green pin and red pin are in straight line. Right? Now let us see. Here what you find, that all the pins are in straight line. Right? Now what have to do? Now take out the pins. Now take out the slab. Right? And with this, take out this pin also. And now with this pin, make a straight line with this pin. Here you see, with the red pin and green pin together, make a straight line at this point. Now remove this point, remove this pin here and make a straight line. What we get, that is the emergent ray. And what we find, that this ray, incident ray, we got this one incident ray PA and RS is the emergent ray. Now you have to take this point R and Q, join Q with R, join this point Q with R. Here we are joining Q with R, and here also what you have to do, make a normal here. At this point make 90 degree and make this normal. Okay. Now what you will find, that you will find that this angle is 30 degree. If you measure this angle, that is angle of refraction, here you see this is the emergent ray and QR is the refracted ray and R is the emergent ray, right? Now if you measure the angle, we found that the angle of incidence is 30 degree. Let us measure the angle of refraction. The angle of refraction, if you measure, we will find that the angle of refraction is measure with the angle with the normal 20 degree, right? The angle of refraction, that is I1 you can write, and angle R1 is equal to 20 degree. Angle of refraction is 20 degree, right? Again here, if you measure the angle, this angle with the normal, then what you will find, you see this angle, it is also 20 degree, right? This angle is also 20 degree, that is R2, angle R2 is equal to 20 degree, and angle, if we consider as I2 or angle of emergent, that is also 30 degree. If we measure this angle, let us measure the angle of angle of emergence. Let us measure this angle with the help of this protractor. You see that this is exactly 30 degree. That is I2 is 30 degree. That means we got the correct answer. That is angle of incidence and angle of emergence will be same. That is 30 degree, right? Now what have to do? Now we have to find the refractive index. We know that to find the refractive index, that is refractive index of mu, refractive index of glass with respect to air, right? We will find by sin I, by sin R, that is sin 30 by sin 20. We will not find the refractive index in this method, but let us find sin I by sin R. Here you see, this is angle I1, right? That is sin I1 by sin R1 is the refractive index. Here sin R2 by sin I2 is the refractive index we will find. Here, right? First I will find sin I. This is angle I. For that, with this point, make a circle. Suppose we take the radius as any point like this, any radius, and first of all make a circle. Let us make a circle with this given radius. Let us make a circle here. We made a circle, right? And here we will get this value, that you get a circle, and with this point make a line here. Join this point, right? And here also you will find that with this point and 90 degree at this point, join this point, but it will be 90 degree, right? We got two things. Now what have we do? First of all, find sin I. You see, this is angle I1, that is sin I1. Sin means perpendicular by hypotenuse. This is perpendicular. PS is the perpendicular, so this is theta. PS and hypotenuse is PQ. Therefore, we have written PS by PQ, right? And sin R1 means this one. This one is sin R1. Sin R1, this one, and we are getting sin. This is sin R1. You see, this one is sin R1. Refracted, not this angle, but we are finding this one as R1, right? We'll find sin R1. Sin R1 is, let us find this one, this angle. That means sin R1 is perpendicular by hypotenuse. Perpendicular is TU and hypotenuse is U, right? Therefore, sin R1 is TU by QU QU, right? Now we know that to find the refractive index, we have to find refractive index of glass with respect to air is sin I1 by sin R1, right? We find sin I1 as PS by PQ, and sin R1 as TU by QU. Therefore, it will multiply QU by TU. Now you find that PQ, this PQ, and QU, both are radius, that will cut. PQ and Q will be cut. Why? Both are radius of the same circle. Both are radius of same circle. Radius of same circle. Right? Therefore, we are getting PS by TU. Now we will measure the value of PS. Let us measure the value of PS. If we find the value of PS, let us find the value of PS is exactly 2.2 centimeter. Here we have written PS is equal to 2.2 centimeter. Let us find the value of TU. Here is TU. Let us measure the value of TU is 1.4. Here written TU is 1.4 centimeter. Right? Now I put the value here, that is PS by TU, that is 2.2 and 1.4. If we divide 2.2 divided by 1.4, we are getting 1.57. Therefore, we are finding the refractive index of glass with respect to air is 1.57 approx. Right? In this way, you can find the refractive index. Now, I will show you what is the lateral shift. For that, what we do? This is our incident ray. Extend this incident ray. Extend this one, right? Let us extend this incident ray. We are extending this incident ray. Right? Now you will find that at this point R, let us draw perpendicular on the line. Yes, from here to this is the perpendicular line. Now if you measure this line, we will get the lateral shift. Let us measure this distance. The distance is 0.9 centimeter, right? Therefore, lateral shift we are finding as 0.9 centimeter, right? I will find lateral shift, that is lateral shift is 0.9 centimeter. Here you are writing lateral shift is equal to 0.9 centimeter. In this way, you can find the lateral shift and also the refractive index of a glass prism, right? We have found the refractive index and also the lateral shift. Lateral shift is 0.9 centimeter and refractive index of glass with respect to air is 1.57 approximately. And this is our correct answer. And also you can find that this experiment is correct because you see that angle I1 coincides with angle I2. That is, angle of incidence and angle of emergence is same, right? right? Therefore, we are finding that this experiment is correct and find the refractive index as 1.57 and lateral shift is 0.9 centimeter, right? Dear friends, if you like this video, please subscribe, like and share. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.